In this video, I will provide you with a few ideas for actually framing the loft. And we'll start with a simple one here that I've already drawn. And this one here will require a ledger with some joists that would attach to hangers. And it's not uncommon for an engineer to require lag bolts. So let's say you might need a 4-inch lag bolt. That would give you 1.5 inches plus 2 inches into the framing stud, and I would imagine that they would be at least 5/16, possibly 3/8 bolts, but again, this is just speculation. I'm not an engineer. And another method for attaching the ledger would be using 16D nails. 3 or 4 might be required for each stud, and another view of it there. And this drawing here has a single joist on the end. The next one will have a larger joist. Now you can actually use a double joist here or a beam. Here's the beam that I'm talking about. It's not uncommon to have something like this at the edge of a floor. And this would give you some more strength also if you were going to use it to connect a stairway to. So this one will have a post underneath it, 4x4 if you're going to use a 4x12 beam, something like that. You might need a 6x12. Might need a bigger post in here. And don't forget that you might actually need a footing underneath this, and you'll see more of that in the next section. Something like this, I don't know if it would require a footing or not. It would depend upon the width of your existing footing, kind of a thing. But you can just see here where the beam is sandwiched in between two framing studs, and the ledger just simply butts up against there, and then you could just toenail this into the beam, and then of course nail right into the framing stud also. Get a nice connection. Now I wanted to show you some midspan blocks. A lot of times they're required for widths over 10 foot wide. You got to have midspan blocks, and they really do a great job at keeping the joists or preventing them from twisting and stuff like that. But I do have to say, this is something that a lot of people miss, is they squeak sometimes. This is where your squeaks come from in your floor sometimes, so I'll leave it up to you whether you want to install them. If you do, stagger the blocks so that you can nail them. You can face nail it. You can see here where you could face nail it on this side and then face nail it on the other side and then work your way down all the way. So that would be it for this one here. I don't know, I can't give you any recommendations for strengthening the footings for something like this. That would be something that, like I said, you would need to check with an engineer on. But if your footings are strong enough, something like this would definitely work. Next up will be to have a beam that will support the joists. These walls and footings, of course, won't be. You will have the wall here and then the beam. And this will be transferring the load of the floor here to each post and then down to the footings, which you would probably need to install a footing for this type of design here. Take a look at the footing, and again, the size I wouldn't be able to provide you with, but you would need one on each side. Kind of just giving you an idea here what it would look like. You can't do this when you're working out on the job. The joist hangers, again, will attach to the joists, will sit in joist hangers and attach to the ledger, which a ledger will, of course, be either nailed or you would use lags to attach it to the wall framing. Kind of going around, there are the hangers again attaching the joist to the beam. View from the bottom, the other angle there. Let's go ahead and take off over to another suggestion that I have. Let's just say that you're thinking you're going to need a 6x12 or a 6x14 for something like this. Well, you might be able to use a 4x12 for something like this, or a 4x14. If you put a post in the center, this would kind of cut the load in half, the structural load from the floor. So just kind of wanted to throw in another idea out there. And again, if you were going to build a wall across here, you could also use the wall to help support. The wall would just come off of the end of the post, and you could basically put the post inside of the wall, if that makes sense. Just kind of giving you another view here. Something else you're going to need are fire blocks. This will prevent any fire from that. If there was a fire underneath this floor, the fire or the flames will not come into this area, or I should say at least it has like a 1 hour burn through. And something else about fire blocks is it also prevents oxygen from fueling the fire. If this was the only source of oxygen and you don't have this block here and it's pulling oxygen from above, then these fire blocks are going to be helping you there too to prevent that from happening. Now, one more thing, if you do this design, I already talked about this footing here, but you also might need to create an additional footing underneath the existing footing. And again, I'm just kind of throwing something out there that I've done in the past when an engineer might have actually required something like this. And I hope that makes sense. Next up, let's take a look at another problem you might be running into if you're going to be building a loft in your garage. The two biggest problems are going to be headroom and where you can actually locate a set of stairs to get up into the loft. So here we have a conventionally framed garage with roof rafters and rafter ties. And here's our little loft in the back. And you can make your loft any size. I think you get the point by the time I'm done with the video where I'm actually going with this. Now this loft here is actually built in a garage with 10-foot walls, and it's at the top of built to where the floor would be even with the top of the framing plates. Let's go ahead and remove the roof and the rafter ties, give you an idea. Here we can see the floor is built even with the plates. You have plenty of headroom down here. You just don't have a lot of headroom at the top, as we can see here. So we can actually lower the floor while keeping in mind that we need to make sure that we have enough headroom at the bottom. Now, a lot of times your standard walls are going to be 8 foot tall. And your roof pitch, I think this is a 6-in-12 roof pitch, probably about 24 degrees, I think, if I got that number right. And you've got a little bit of room for a loft. You can put the floor down. Here you can see where, and I think I'm at scale here at about 6 foot, and down here. So I would say the minimum you could go, and I don't know if this is, if you're going to go through through your building department, then you would have to verify all the information with them. But I think 6'8", I want to say, is the lowest, but it might actually be 7 foot or 7'1" for the framing, for the lowest ceiling you can go. So my whole point of the headroom here is that you might not have enough room to put a loft in. So if you just want to build something for storage, that's one thing. But if you want to build something that you can, maybe you want to turn it into another room or use it for an office, something like that, then you might not have a lot of usable space if you have 8 foot tall walls and a lower pitched roof. And of course the opposite would be if you had 10-foot walls and a 45-degree pitch or a 12-in-12 pitch, you might have a lot more room. Another problem you're going to face will be a stairway. Where the heck are you going to put it? We can see here that I can't stand here. If I built a set of stairs off to the right or the left side, it's going to have a problem with the headroom. So you'd probably have to remove a collar tie or two. And if that's the case, you might need to figure out a way to relocate them. And so a stairway off to the side might require more building modifications, where a stairway in the center might not, but if you built this in a garage, this isn't going to provide you with a lot of usable space. You're not going to be parking your cars in the garage anymore. So, and the reason why I'm providing you with this info is just to prevent you from doing this. I've dealt with a lot of people who actually don't plan anything. And I haven't said this in quite some time, but planning, of course, is the most effective way to actually build something or to know if you can actually build it. And here you can see if it's located in the center, you'd probably still need to remove one of the collar rafter ties, but you'd be able to walk up the stairway without too much of a problem. But now let's say you wanted to put a set of circular stairs in, or spiral stairs I should say, and you see a lot of those going up to a loft. Don't forget that they take up some space. I think they require at least 7 feet by 7 foot, and this is the minimum. I think they might even require, I've seen them where they require 11 foot by 11 foot. So if you're actually building a loft, you might have a problem installing a spiral stairway where you're thinking, hey, this is going to provide me with the answer, and it might not. So stairway and headroom is definitely going to be a big problem. And last up on the list, I kind of wanted to give you an idea. Remember I said this was a 10-foot wall and a 6 and 12 pitch. And you can see here, this is a 4-foot sheet of plywood that I probably have about 8 foot of space here where I don't have to duck. And if you don't want that, then you might have to, like I said, do some modifications to the building, which might require you to raise a section of the roof. Now, if you're going to put the stairway on one side, you could always put the stairway on the side and then remove a few rafters. So you would have a roof on this side, and this one here might be flat or sloping up in this direction, something to give you a little more room. So, and again, you might want to do that with the whole room. You want to put a room up here, and you might want to remove the entire roof and raise it also so that you do have some headroom. So anyway, that's it for this video. I am going to make another video. This was a request for one of the viewers. I'm going to make another video on how to actually build the floor, a few different ways to build a floor for a loft like this one here in a garage. And for those of you looking for a more interesting project, what about this? A 1-bedroom apartment or 1-bedroom house, however you want to look at it, over a 2-car garage. And the only difference in this one here, I'm still going to keep it in our 20 by 24 video playlist series for the size of the building, but this one here, I extended the length 2 feet, and that was to give the bedroom and the living room a little more room. And in this video here, I went ahead and I moved the doorway to over here because I'm going to have plumbing in this wall, and I will be providing another video on that also. So not too big of a deal. Instead of walking in from this side over here, you're going to be walking in from this side, and that's probably not going to be that big of a deal. Let's go ahead and remove the floor framing. Take a look at the wall framing here. Just kind of whip around the building. And this is pretty much the same garage and framing as one of our previous videos. So I would suggest checking out all of the videos before designing and building something like this anyway. Next up, let's go ahead and take a look at the modifications that I will have made to the floor framing. And one of them will be to move the head out a little further this way so we can miss the plumbing pipe for the wash machine that will be located on the lower level, along with moving the doubler back a little bit to line up with the bathroom wall. And we are going to be installing some blocks 16 inches on center instead of adding doublers and relocating the joist to mess up our floor sheathing. And trust me, with the prices of lumber, I don't think they're going to be going down a lot. However, they could be going up even further in the future. And if that's the case, then you are definitely going to want to get your floor framing joist so that you don't end up with very much scrap floor sheathing. And these blocks can be nailed with 16 D nails, probably about 3 or 4 on each side. And I'm going to go ahead and show you where the walls will be located so you can get a better idea why they're being installed and where they are being installed. And of course, it wouldn't hurt to check with your local building and safety department to verify all of the information in this video, because your engineer might want to have a doubler in there, and you might need a doubler to help support the roof or ceiling framing also. And you can see here where we put a couple of blocks underneath this section of the wall. And even though this joist is in a spot to where all we would need to do would be to add another full length joist to it here, that's going to increase the cost of the building a little bit instead of just using a few blocks. Let's go ahead and remove the walls and then take a look at our stairs. So let's go ahead and zoom into the head out connection and then to the bottom of the stairway where the stringers attach to the concrete floor with our treated lumber and our pins. And for those of you who need more information about building a straight set of stairs, guess what? I have a few books that you can check out, and you can find those books at our website or simply type "How to Build and Frame Stairs" into your favorite search engine, and I'm sure they will pull up the books. And according to a lot of the people who have purchased the books, they have made a big difference when cutting all the stringers, designing everything, and then building the straight set of stairs. So with that said, let's go ahead and install the floor sheathing and then the wall framing. And next up, we will just take a tour of the wall framing. And for those of you who are looking for some type of a lumber list, then I would simply suggest going around and counting the amount of studs you need along with the framing plates. And that's usually not that difficult to do. And of course, we are in the bedroom here. It's a small bedroom. I think it's about 11 foot by 13 feet. So not that small of a bedroom. And I think we have a 4 foot by 3'6" window here. And don't forget to make sure that your windows work with the fire egress codes. And of course, this window as a sliding window should. Take a look at the kitchen window, and that's going to be 3 foot by 3 foot. And of course, we got a nice size closet here. And then our bathroom. And here we have a 4 foot wide, 18-inch tall window. And your window might need to be a little smaller depending on the bathtub or the bathtub surround you're going to use. And we are also going to have a window in here to provide us with a little more light for the stairway. And this window right here might need to be tempered glass. And now we will take a look at the outside here. Lower window in the garage, upper window in the living room, and then our bedroom here. Front of the house or front of the garage and the loft area, depending upon what you will need to refer to it. And then our kitchen, closet, and bathroom, along with no windows over here because of some of the plumbing pipes that are going to be coming down in the wall there. The bathroom door, kitchen area, right here's where the refrigerator is going to go. And you can always make the kitchen a little larger by making the closet a little smaller, or by extending the wall here. You can see here where this wall here can come out a little bit to give you another foot or maybe 14-16 inches of cabinet area. Next up, let's go ahead and add our ceiling joist along with our drywall backing for the corners and our access hole. And the joist here will be spaced 16 inches on center, the same as our roof rafters. And you might need to use 2x12 or 2x14s in the area where you're going to have 24-foot spans. And it might even be easier for you depending upon the lumber in your area, because I've heard about a lot of people complaining that they can't get lumber maybe longer than 16 feet. And if that's the case, you might want to install a beam in this area here, especially if you want the floor to be level, because you might be using it for something in the future. And let's not forget that if you refer to the attic as a storage area on your plans, then the ceiling joist might turn into floor joist and need to be even larger. And let's keep in mind that this video, even though I am providing you with lumber sizes, you might need to contact a structural engineer to verify those sizes along with the other parts of the building. Next up, let's go ahead and install our roof rafters. And I'm not going to go over a lot of the detail here because I have done that in quite a few of the other videos. So again, go back and check out some of those if you need a better view of this, because this is the same roof that I have used in a couple of the videos already, and it has a 8 and 12 pitch, and I believe that pitch comes out to be around a 33-34 degree angle, and a nice angle sometimes for allowing the snow to fall off of the roof. However, I'm sure that is going to depend upon the roofing material you use, because I've seen some slopes that are pretty steep with a lot of snow on them. And if you live in snow country, I'm pretty sure you have also. Next up, let's go ahead and zoom in on the corner here. give you an idea of what the fascia board and the gable studs are going to look like at this area here. And now let's go ahead and take a tour of some of the inside wall framing and ceiling joist connection. And again, here we have our ceiling backing, a flat 2x6, and we notched our joist block over it. You can always take the backing to the block on each side and then avoid notching it. And again, I don't think there's really going to be a big difference there. I know a lot of people ask me, hey, what would you do? And to be honest with you, I like this connection here. And of course, our access hole here with our hangers. Zoom in on the backing here. You might want to put this backing on after you install the roof rafters. And that might be something you want to do on all of your ceiling backing. Next up, let's take a look at the view out of the kitchen window that could be a problem because of the overhang and the slope of the roof. And you're going to have the same problem with the living room window also. And to fix that, you could either change the slope of the roof to make it lower or reduce the length of the overhang. For example, the overhang in our video is about 2 feet. You could always reduce it to 1 foot to solve that problem if it is a problem for you. Another view of the ceiling backing along with the ceiling backing on the other side. And we will also be taking a tour of the lower wall framing for those of you wondering just why in the heck we're spending so much time on the upper wall framing. And again, you can see here where the living room window has a little bit of an obstructed view from the roof overhang. And of course, our stair landing or upper part of the floor, this needs to be at least 36 inches for most buildings like these. And I believe most building code books refer to the length of this right here as applying to a building with less than 50 occupants. A view of the bottom of the bedroom door, corner of the bedroom framing. Next up, let's take a look at the other corner of the bedroom framing and continue around the room here to the door. And next up, let's go ahead and take a look at the bottom of the closet door, and you can kind of see here how the framing for this area is also going to be assembled along with this side. And if you're dealing with an uninsulated wall and you need to overspan one of the wall framing studs or even a couple of them, instead of laying everything out at 16 inches on center and then needing to install another stud that's only going to be a couple of inches away from this stud, you could simply leave that framing stud out. And I've done that plenty of times on non-load bearing interior walls. Kitchen wall here, bathroom door. And again, we moved the floor framing from our other video back a little bit to line up with bathroom wall here to provide us with a nice finish. And of course, I don't have the studs located, especially in the bathtub area here. I will be changing the location of those studs in our next video about the plumbing. In this video, I will provide you with a few examples on how you can install the rough plumbing for our 2-car garage with the loft or apartment. And we will start with the vent sticking out of the roof sheathing. And this vent is for the wash machine, which is going to have a 2-inch pipe. And even though it might look like I'm going a little faster through this video, I've cut it up into a few sections, so you're going to get a lot of different views. And some of them might actually be the same throughout the video, except we might not have parts of the foundation or framing. And I might make another video to provide you with a little more information about a variety of different things you can do on this same project that might or might not save you a few dollars. So here we have the kitchen drain, hot water, cold water, and of course we're going around the wall framing stud. For those of you who might not be familiar with this, you're usually not allowed to drill through a 2x4 wall where you have the king stud and the jack stud. That might severely weaken this section of the window and wall framing. And of course, now would be a good time to point out that you should check with your local building department and plumbers in your area to verify all of the information in this video. And here we have the bathroom sink. along with the toilet and the water supply for the toilet, and our bathtub. And another thing you are going to want to do will be to keep all of the plumbing inside of the wall framing and floor framing if you possibly can. Another important part of installing plumbing. And as I said, we are going to be removing some stuff to provide you with different views. And here you can see where the plumbing vent pipe for the bathtub, toilet, bathroom sink, and kitchen sink would look like without the wall framing. And of course we have our vent for the laundry or the wash machine. Next up, let's go ahead and take away the floor sheathing so that I can show you how the water supply pipes will be going through the floor framing joist, along with how you might need to notch out some of the framing to install larger pipes like the 2-inch pipe for the wash machine. And in a moment here you will see where you won't need to do that to the smaller pipes that we're going to use for the bathroom sink or kitchen sink that's going to have an 1.5 inch pipe. So we are going to be drilling through the floor joist so that we can run our water supply pipes in the floor framing, and we will be building a little ceiling or a little soffit to cover the pipes that are going to be sticking below the joist. And it's often easier to do something like this in a garage where you're not worried about the ceiling. However, I rarely see plumbers do it, and I think that's because they're trained to keep everything inside of the floors and the walls. However, in my opinion, you can do something like this and install all of your straps on the inside for the framing plates, so they won't create any problems for the exterior or the interior finished materials like siding or drywall. And of course, you can save some time by not drilling as many holes through all of the framing materials. Another big plus with doing it this way. Next up, let's take a look at the bathtub drain and water supply pipes. Hot and cold water along with the shower valve, and we will have the lower section here for the bathtub, upper section for the shower head. Next up, let's take a look at the sink here, and even though I won't be providing you with details, I want you to go through the video and check out how the hot water is going to be on the left side of the fixture, cold water is going to be on the right side. However, if you mess this up on a sink, it's not really going to be that big of a deal. You can just get longer hoses that you will be using to connect the water supply to the faucet. Instead of having the connection hose go straight up, it'll simply crisscross. This one will go over to here, this one will go over to here. And trust me, I've had to do that myself a few times. And of course, the kitchen sink and the end of the line for our water supply pipes. Let's go ahead and pan out a little bit, give you a view of everything there. And then we will remove the floor joist so we can get a better view of the water supply pipes without all of that stuff in our way. So let's go ahead and start with the water supply coming in, cold water coming in to a gate valve or a valve that you can use to shut off the water supply to the garage and the apartment. So cold water going up here. Coming up here, cold water is going to continue up to feed all of the cold water for the rest of the building. However, it's also going to branch off and go through the water heater. And of course, this is where our hot water comes from. The cold water will go into the hot water heater and then come out nice and toasty. At least that's hopefully how it's going to work. Now, here's something I like to do, especially on a job like this, even though it might not require it, and that would be to use 3/4 inch pipe to allow more water to flow to certain fixtures. Now, if I'm going to a bathroom sink and a kitchen sink, I could probably get away with just running 1/2 inch lines from this point here and this point here. So you're going to want to think about that when you're reducing the pipes down as to where you're going to position the reducer. Before the pipe going to one of the supply sides or on the other side. And this might not make a difference here, especially if we are using some type of water saving fixtures that will also be reducing the flow rate of the water. And this will also be something you will need to consider when planning what size pipes you're going to use. So again, 3/4 inch pipe going here. We got 3/4 inch pipe here, reducing down here after we get past the washer and dryer lines, and then reducing here and then reducing here down to 1/2 inch to go to the kitchen sink. And then here we have our stub outs that will be cut after the water water pipes have been tested or filled up with pressurized water. And then after all of the walls have been finished, cabinets have been installed, we can go ahead and cut these pipes off to install our water shutoff valves. Next up, let's take a close-up view of how the 90s are working here. And even though I'm sure most of the people know this, you can always stop the video, pause it at any time if you need to examine something a little more carefully. And of course, this is what I was talking about when I said that it makes my wife a little happier to reduce after the toilet to avoid a problem that you might not be dealing with low flow shower heads. However, years ago, it wasn't uncommon to have someone in the shower and then someone else flushing the toilet, only to create a temperature change, and then within a few moments someone in the shower screaming because the water temperature got a little bit warmer, because instead of now having water dedicated to only the shower, you now have water going to the toilet and the shower. And I know some of you think, wait a minute, who's going to use the toilet when someone else is in the shower? Because a long time ago, when we only had one bathroom and 6 or 7 people living in the house, it wasn't uncommon to have someone in the shower while somebody else was using the toilet. And that might be a little too much information for most of the viewers. But what can I say? Just trying to keep the video entertaining. And of course, another view of the water supply lines to the wash machine. Next up, let's go ahead and bring back the drainage pipes. And we are going to take a look at what the drainage pipes might look like without the concrete slab in the way. And we are going to be using a 3-inch pipe here, along with our combo fitting, reducing it down to 1.5 inches, and then using a sweep fitting or a long 90. And this will happen over here also, kind of the same setup, 1.5 inches to pick up the bathroom sink, and then a 3-inch line going to the toilet with a clean out, along with 1.5 inch line coming off for the bathtub. And we are going to have 2 clean outs here. We're going to have one for the toilet line and one for the bathtub, even though you're probably thinking, wait a minute, what do we need something for just this line here? However, I would install the clean out, and you might consider installing a clean out on each one of the lines here. However, I will leave that up to you. And of course, our toilet, reducing down to a 2-inch vent pipe. Everything else over here is going to have 1.5 inch vent. And I am also going to go through the roof with each one of these pipes instead of connecting them together inside of the attic, to provide you with another example of something that might be easier for you to do, including the kitchen, where we have our drain line here and then our vent coming up and around the king stud so we don't have to drill through it. And then we're going to need a 2-inch pipe for the wash machine drain, along with a 2-inch pipe for the vent. And hopefully by now I have provided you with all of the views or angles that I possibly could for this project, so that you can get a pretty good look at how the plumbing works. And thanks for watching. If you enjoyed the video, let us know by hitting the thumbs up button or letting us know in the comment area.